Electrochemistry homework. I opted to do one large problem rather than several small problems. So every question you're going to answer for the homework is based on this reaction here. So first thing we're going to do is balance this in an acidic solution. Then we're going to follow that up with a basic solution, identify what's being oxidized, reduced, etc. So let's just give this a go. So here is our reaction. And the first thing we need to do when we're going to balance one of these reactions is we need to separate into our half reactions. So I'm going to have my iodine in one reaction, reactants on the reactant side, products on the product side. And I'm going to have my manganese in a second half reaction, again, keeping the products on the product side and the reactants on the reactant side. So now I need to balance all elements other than oxygen and hydrogen. So now that's done. And now I'm going to balance the oxygens, then the hydrogen. So first I balance oxygen by adding water. So I add 2 water to the product side of the manganese half reaction in order to balance those oxygens. So now I need to add hydrogen ions in order to balance the reactant side. Now I'm going to balance charges. Starting with the iodine reaction, I'm going to put 2 electrons on the product side in order to balance the charge across the arrow. And for the manganese reaction, I have 4 positives and 1 negative, so I have a 3 positive on the reactant side, but I'm neutral on the negative side, or on the product side. So I need to put 3 electrons here. Now, in order to balance this, now I need to make sure that my electrons are the same. So I need to find the least common factor between my 2 and 3, and that happens to be 6, so I'm going to multiply the top reaction by 3 and the bottom reaction by 2. And when I do that, then I don't have 2 of those. I have 6 iodine. I'm going to put all of my reactants down first, and I'm going to even put my electrons down as well, and then we can cross out. Then I have my arrow, now all of my products. So now I can cross out what is alike. I have 6 electrons on both sides, so they both are going to get crossed out. And I think that's it for my likes. So balanced in an acidic solution is this reaction. Now, to convert this into balanced with a basic solution, I need to neutralize these acidic hydrogen ions. So I'm going to add 8 hydroxides to both sides, because what I do to one side of the arrow, I have to do to the other. And then I have formed 8 water molecules on that side. Looks like I'm running out of room. So I have 4 water molecules on the product side that can cancel out with 4 of these water molecules. So balanced in a basic solution then would be this reaction. Then I have what's being oxidized and what's being reduced. So number 3, what's being oxidized, I go up to my half reactions. Remember, oxidation is loss, so oxidation has electrons on the product side. So the I minus, the iodide, I minus, or iodide is being oxidized. So what is being reduced? Reduction is gain. So reduction has electrons on the reactant side. So it's the MnO4 minus that is being reduced. Number 5, let's see, what was number 5? I think that was the cell notation. Write the reaction in cell notation. Use platinum as an inert electrode if needed. Well, all of my items are aqueous, so I am going to need that platinum electrode. So I start by writing platinum, and it is a solid. I give a straight line showing I'm changing phase. Then I have my reactant, and I have my product, both of which were said to be aqueous. Double line showing my salt bridge, and then I have my reactant of my cathode, and the product of my cathode. Straight line showing change of phase, and then the platinum solid. Now when you go to enter this into the text editor, these straight lines here, at least on my keyboard, are shift. I have a key, it's above my enter key, and there's a backslash and a straight line. So on this one key, it would be shift, and then this button here would give me a straight line, just for some formatting. And then number six is what is the oxidizing agent? Well, the oxidizing agent is the thing being reduced. So you can just copy that down. And number 7, what is the reducing agent? Well, the reducing agent is the thing being oxidized. So that should be a quick and easy part. And then number 8 is to calculate the standard cell potential for this reaction. Well, let's look up those standard cell potentials. So I go back up to my half reactions, and I'm looking for I- forming I2 with 2 electrons. Well, you'll find those standard cell potentials right down here, and they are organized kind of by primary element. So we can go in alphabetical order. And then I'm looking for iodine. Here's iodine 2 with 2 electrons goes to iodine 1. So I have 0.54 for that cell. So that is my anode. And remember, my is going to be the E0 of the cathode minus the anode. So what I just looked up was the anode. So I'm going to have 0.54. And that was positive, but I am subtracting. That's volts. So now I need my E of the cathode. So the reaction I'm looking for is this MnO4 minus reacting to form MnO2. Again, in alphabetical order, I'm coming down here. Here's MnO2, 2 waters, but that forms the magnesium hydroxide. So that's not the right half reaction. What I'm looking for is this one. And you can double check your work as well with this half reaction. So we should have 4 hydrogen, 3 electrons, and that's what we have here. So that half reaction is a positive 1.68. So that number goes here. So the E0 of the cell is then a positive 1.14 capital V volts. Number 9, is this a spontaneous reaction? Well, yes, this is going to be producing electricity here. So yes, this is spontaneous. And number 10, we were asked to find the delta G0 of the reaction. Well, the delta G0 of the reaction is going to be equal to the NFE, the negative NFE. And this E is here. So what we don't know then is the delta G. We have the number of electrons, and the number of electrons is the balanced what we have right here. So it's that 6 that I'm looking for, and that's why I wrote it out that way. So we have a negative 6 times Faraday's constant, 96485, and that is coulombs per moles of electron, and that's going to be multiplied by the E that we found, 1.14. A volt is a coulomb, is a joule per coulomb. So those cancel, moles of electrons cancel, and that was, I didn't put moles there. So then we're left with joules. So when we calculate this out, get a negative 6.59957, and that's in joules. And it would be easier if we wrote that in kilojoules. Now that's 2 significant digits. I think we should probably have 3 sig figs there. So scientific notation would take care of that. But as you can see from our previous chapter in delta G's in our thermochemistry, that this is a spontaneous reaction, and it is spontaneous because our delta G value is negative, and that is an awful large delta G value, so it's definitely spontaneous. Now you should also be able to calculate K values at standard or non-standard conditions. This particular reaction did not lend to that, so make sure that you can do that as well. But number 11 was a concentration cell. So given these conditions, what is the cell potential if those concentrations were available? So I'm going to put that information here. Now we still need some of the other information that we had. So in order to calculate the E of this cell, then, this is the E of the concentration cell, we need the E naught value, which we calculated. And then since we're going to call this at standard conditions, then we can use this equation here. And then we need our Q. Now, remember our Q value from the equilibrium chapter. We have our products, concentration of our products, over the concentration of our reactants. So now we just plug in the values that we know. We know that this was 1.14. We know our N was 6. And we've been given these concentrations. So plugging all of that into the calculator, you should get a value that looks like 1.1198. We can only report to the hundredths place here, so this would be rounded 1.12, capital V, volts. Remember, with any problem that is like this, I need to see answers. You can number them. Just use the little numbered list thing and start giving me answers. Format as best you can. Send me your work with the optional quiz assignment after the quiz. Do not email me your work.